So in today's video, we're going to be talking about how to solve 3 by 3 systems using technology with matrices. So today we're going to learn how to solve systems that look like this. So you may be looking at this problem and wondering, didn't we already learn how to solve this system? And you're absolutely right. We learned how to solve 3 by 3 systems using algebraic methods in the last video. So today we're going to actually learn how to solve the same type of problem, but we're going to use an entirely different method. Today we're going to be using matrices with Cramer's rule to solve 3 by 3 systems. So if a 3 by 3 system has one solution, remember that it'll be represented by a point which is x, y, z. That is also called an ordered triple. So here's our problem solving strategy for today. We're going to take a 3 by 3 system of linear equations and turn it into a matrix equation that we can solve using our graphing calculator. So let's start off by talking about what is a matrix. A matrix is a rectangular arrangement of numbers in m rows and n columns. The dimensions of a matrix with m rows and n columns is m by n. So you can see in this example here, we have a matrix with 2 rows and 3 columns. So that is called a 2 by 3 matrix. So an entry in a matrix is called an element of a matrix. So notice that this example matrix has 6 elements in it. A matrix can be named by a capital letter. So if you see a capital letter with brackets around it, that means that we're talking about a matrix. So notice that this example matrix is called matrix A, and that 4 is an element of this matrix. So here's what we're going to do to solve these systems using Cramer's rule. So we're going to start off by making sure that all our equations are in standard form. Then we're going to set up the coefficient matrix A and note its dimensions. Then we'll set up the constant matrix B and make sure to note its dimensions. And then finally, we'll use Cramer's rule, which tells us that xyz equals the inverse of A times B to solve the system of equations. So before we get started, just to remind you, standard form of a linear equation in 3 variables is ax plus by plus cz equals d, where a, b, c, and d are constants. So an example of this is 2x minus 3y plus 4z equals 7. Notice that in standard form, all our variable terms are on the left side and our constant term is by itself on the right. And also remember that the variables are in order going x, y, and then z. Another thing I'd like to remind you of is the parts of an equation. Remember that the number that is associated with the variable is called the coefficient. So in this example, 3 is the coefficient because that is the number that's associated with x. The two numbers that are by themselves, 4 and 7, are called constant terms. So let's try solving this system using the steps that we just talked about, and let's work on setting up these matrices. So first we want to check that our equations are in standard form, and notice that they all are in standard form. So we can go ahead and set up our coefficient matrix. So our coefficient matrix A is going to look like all the coefficients from our equations just written out in order. So we start off with equation 1. So notice the coefficients are 2. And then remember the coefficient of y is going to be 1 because if there's no coefficient written, there's an implied 1 there. So we have 2, 1, and then negative 4. So that's going to go into the first row of our coefficient matrix. Now we're going to go to row 2. So the coefficients are 2, 4, and 2. Okay, so we're going to write that in row 2. And then the next row, it has coefficients 6, negative 2, and 4. Okay, so that's going to go into row 3. So that is how we set up our coefficient matrix. Notice that there are 3 rows and 3 columns, so this is a 3 by 3 matrix. So now we're going to set up the constant matrix. What we're going to do to set up the constant matrix is we're going to write out all these constants that are on the right side of our equations. So the constant matrix B is going to look like this. We're just going to write out 7, 40, and 44. Okay, notice that this matrix has 3 rows and 1 column, so this is a 3 by 1 matrix. So now what we're going to do is we're going to write a matrix equation. So remember what I had told you is that we were going to take this 3 by 3 system and turn it into a matrix equation. So I'm going to write my coefficient matrix. So I have 2, 1, negative 4, 2, 4, 2, 6, negative 2, 4. Remember this was my matrix A times my variable matrix. Okay, so my variables in this system are x, y, and z. And that is equal to my constant matrix, which is 7, 40, and 44. Okay, so in other words, I can basically say that matrix A times x, y, z is equal to my constant matrix, matrix B. So now what I'd like for you to think about is how we would solve this equation, right? So we're always trying to isolate variables in algebra and solve to find what are the values that equal the variables. So here I have a matrix equation. So I want you to kind of think about how we would use the algebra that we know to solve this equation and figure out the values of x, y, and z. Well, remember, our strategy in algebra is always to undo the operations in an equation using inverse operations. So, for example, if I was trying to solve the equation x plus 2 equals 5, right? So I would look at this equation and say, well, I have a plus 2, so the inverse of plus is minus. So I would minus 2 on both sides of my equation, and that would give me x equals 3. So what we need to do here to solve this matrix equation is to figure out the inverse of A. Well, the inverse of matrix A is written like this, okay? So we write matrix A, and then you do the superscript -1. So that actually represents the inverse of A. So what I'm going to do to solve this equation is I'm going to multiply both sides by the inverse, because remember, anything I do to one side of the equal sign, I have to do on the other. So that's going to be how we solve this matrix equation to figure out the values of x, y, and z. So you can see what happens here is when I multiply matrix A by its inverse, these two terms will cancel each other out. So I'm going to be left with xyz equals the inverse of A times B. And so this is how we're going to solve for our variables. And as a matter of fact, this is actually what is Cramer's rule. Cramer's rule tells us that xyz equals the inverse of A times B. So I've given you some background on how we set up these matrices and how we're going to go about solving, but we haven't actually solved the system of equations yet, right? So for this, we're actually going to go to our calculator, and what we're going to do is we're going to enter these matrices, and then we're going to apply Cramer's rule to figure out the values of x, y, and z. So now let's go through doing the part in our calculator. So we're going to start off by entering matrix A in our calculator. So whenever we're doing matrices in our calculator, we need to first pull up the matrix menu. So you can see here where it says matrix in blue, that's going to let us get to the matrix menu. So I'm going to click second, and then I'm going to click this button right here to open up the matrix menu. So I'm going to arrow twice to the right so I can go to edit, because we need to go into the edit menu whenever we want to enter new matrices or, fix any of the values for any matrices that we have entered. So I'm going to choose matrix A, and I need to first tell the calculator the dimensions of A. Remember that A is a 3 by 3 matrix, so I'm going to do 3, enter, and then 3, and then enter again. Now I just go ahead and enter the elements of A, and then what I'm going to do is I'm going to type each one in and then push enter after typing it in. And then what it's going to do is it's automatically going to advance across the rows. Okay, so we're going to go across rows as we type in these values. So for example, I do 2, enter, 1, enter, and then -4, enter. Okay, and then I do 2, enter, 4, enter, and then 2, enter. And for row 3, I do 6, enter, -2, enter, and then 4, enter. Okay. And then it's very easy sometimes to make a mistake when typing or to, miss a negative sign or something. So you just want to look and just compare and make sure that you've entered everything in correctly. If everything looks good, then you're going to click second and then the mode button, and that'll take you back to the home screen. Now let's go ahead and enter matrix B. So once again, I'm going to open the matrix menu, so second matrix, and then arrow twice to edit. So I'm going to choose 2 now because I'm going to be entering B. And then remember, B is a 3 by 1 matrix. Okay, so first tell it the dimensions, and then I'm going to enter the elements. So 7, 40, and 44. Okay, so now everything looks good, so I'm going to return to the home screen. So now what I need to do is tell my calculator to remember the matrices I entered and then use Cramer's rule to figure out a solution. So what I'm going to do is I go second matrix, and then now from the names menu. Okay, so once you have the values entered, you're going to be choosing the matrices from the names menu, and I'm going to tell it to bring back matrix A. But notice that I don't need matrix A itself, I need the inverse of A. Okay, so I need to use this inverse button right here to get the inverse of A. So notice when I click that, that superscript of -1 automatically shows up. And then I'm going to say matrix B. So I do second matrix, and then once again from names, I choose matrix B. So now I have my equation incorrectly, so I'm going to click enter, and it gives me the values of x, y, and z. Notice that it does give you the values as a matrix. What this is saying is that x, y, z is equal to 7, 5, 3. Okay. But what we should really be doing is writing our solutions as an ordered triple. So we're just going to write this as 7, 5, 3. Okay, so you'll need to do that because that's how the solutions are presented in the quizzes and on the test. Okay, so that's everything that we need to do to solve a system of 3 by 3 equations using Cramer's rule and our calculator. So now we're just going to practice with a few more examples so that you can get used to setting up these matrices and entering them in your calculators. So let's always start off by setting up the coefficient matrix. So my coefficient matrix is going to be A, and I know that we're doing a lot of this on our calculator, and some of you may be tempted to just go ahead and start typing things in. Um, that's okay, but I think it's a little bit better if you just take a minute to write out your matrices because it helps you keep track of all this information, and also it's a good way to, go back and double check and make sure that you've entered everything in correctly. So I always write out the coefficients and the constants before I go to my calculator. So matrix A, remember, it's going to be these coefficients here. So I have 1, 1, and 1. And then I have row 2, which is 2, 4, and negative 1. And then row 3 is going to be 2, negative 4, and 2. And so that is my matrix A, and it has dimensions that are 3 by 3. So now let's write out our matrix B, the constant matrix. So remember, the constant matrix is just going to be all the constants on the right side of our equations. So we have 6, 7, and 0. So this matrix has 3 rows and 1 column, so it is going to be a 3 by 1 matrix. So now we're going to go to our calculator, we're going to do second matrix, and then we're going to go back to edit so that we can enter these new matrices in our calculator. So I'm going to choose enter on A, and I can keep the dimensions the same because I still have a 3 by 3 matrix. And then I'm just going to start typing in my new values, and it'll overwrite what I already have written in my matrix. Okay, so just keep typing. So I have 1, 1, 1, and then I have 2, 4, and negative 1. And then I have 2, negative 4, and 2. Okay, so double check and make sure that everything looks right. And then we're going to click second mode. And then I'm going to go back to second matrix and then arrow over to edit. And I'm going to choose matrix B. I can keep the dimensions the same. And then I'm going to type 6, 7, and 0. So now that I have both matrices entered, I'm going to tell my calculator to do Cramer's rule, so the inverse of A times B. So I do second matrix, and remember now I'm going to choose the matrices from my names menu. So I have A, and then I do inverse, and then second matrix. Once again from the names menu, I'm going to choose B. So when I hit enter, it gives me my solution, which is going to be 1, 2, 3. And remember, we always need to write our solutions as an ordered triple. Okay, so now let's try another example. So let's solve this system. So once again, we're going to start off by setting up our coefficient matrix A. So the first row is going to be 4, 5, negative 6. I'm going to go to the second equation to get my second row. So I have 3, negative 2, and 7. And my third row is going to be my third equation. So I have 7, negative 6, and negative 8. Okay, so once again, I have a 3 by 3 matrix. And now I'm going to do matrix B, my constant matrix. And that is going to be negative 14, 47, and 15. So this matrix, remember, is a 3 by 1 matrix. So I have everything written out. Now time to go to the calculator. So I'm going to do second matrix and then arrow over to edit. I'm going to choose matrix A. It's still 3 by 3. So I'm just going to go ahead and start typing in my values. So I have 4, 5, negative 6, 3, negative 2, and 7. And then I have 7, negative 6, and negative 8. Okay. Double check and make sure that everything looks good. And then click second mode. Now we're going to edit matrix B. So go back to edit, choose matrix B. It's still 3 by 1, so I'm going to leave that alone. And then I'm going to type negative 14 and then 47 and 15. And now I'm going to do second mode. And I'm going to call back these matrices and tell it to use Cramer's rule. So I'm going to do second matrix, choose matrix A from the names menu, do the inverse button, and then second matrix, and then choose matrix B from the names menu, and then hit enter, and it gives us our solution, which we need to write as an ordered triple, right? So our solution is going to be 5, -2, and 4. So that's the solution to our system of equations. So now let's try this example. So we have another 3 by 3 system. So once again, remember, we're going to start off with our coefficient matrix. So we have 10, 3, and 2. The next row from the second equation, so we have 7, 6, and 2. And then the third row from the third equation, we have 4, -3, and 3. So this is going to be a 3 by 3 matrix. And then now our constant matrix, matrix B, is going to be 5, 20, and 7. And that is going to be a 3 by 1 matrix. So I'm going to go ahead and go back to my matrix menu. So second matrix, and then go back to edit. Choose enter on matrix A. It's still 3 by 3. And so now type in the value. So we have 10, 3, and 2. Then we have 7, 6, and 2, 4, -3, and 3. Okay, double check and make sure that everything's typed in correctly. We do second mode, and then we're going to go back to our matrix menu, go to edit, choose matrix B. So we have 3 and then 1. So we're going to do 5, 20, and 7. Okay, so use second mode to return to the home screen. And now we're going to use Cramer's rule. So we do second matrix, choose matrix A from the names menu, do the inverse button, and then second matrix, and then choose matrix B from the names menu, hit enter, and then hit enter again, and it does give us our solution. And we're going to write that as an ordered triple. So we have -2, 3, and 8, which is the solution to our system of equations. So now that you've gotten some practice, you can go ahead and pause the video and try doing this example on your own. So make sure that you practice setting up the two matrices and then entering them in your calculator, and then go ahead and apply Cramer's rule to figure out the solution. So you can see the solution to the system is -5, 1, 2. So here's matrix A, the coefficient matrix. It's 1, 2, 3, -1, 3, 2, and 1, 1, 1. Remember, you need to enter this in second matrix by going to the edit menu. Matrix B is 3, 12, -2, which you can also enter from the edit menu. And then remember, using the names menu, you call back matrix A and then do the inverse button. And then from the names menu, you call back matrix B. And then when you hit enter, it should give you the solution, which is -5, 1, 2. So remember that using technology with matrices and Cramer's rule, you can solve a 3 by 3 system of linear equations. If a 3 by 3 system has a solution, it'll be an ordered triple in the form of x, y, z.